As Australian company Gilmore Space gets close to launching their Australian-designed and built rocket from Queensland, we cast our thoughts back. The late 1960s saw major advances in rocket technology, and humans began reaching for orbit and beyond.
The Redstone is the Army's 200-mile surface-to-surface ballistic missile developed entirely by the scientific and technical team of the Army Ballistic Missile Agency.
The United States had brought 10 Redstone Sparta rockets to Australia in the 1960s for testing at the Woomera Range in South Australia. The first launch was a failure, and when the next 8 went exactly to plan, they decided not to launch the 10th, nor did they want to ship it home. Instead, they offered it to Australia if we wanted to build and launch a satellite. The next hurdle? We had just 11 months to design, build and launch it. And so Wresat, the Weapons Research Establishment satellite, was born. The Weapons Research Establishment was the government body responsible for the Woomera test range. The WRE would later be amalgamated into what is now the Australian Government Defence Science and Technology Group, to provide science and technology support to defence and defence industry in Australia. Wresat was a cone-shaped satellite weighing 45 kilograms, with a length of 1.59 meters and a diameter of 0.76 meters. It was designed to stay connected to the rocket's third stage, giving it an overall length of 2.17 meters. 3 cones were built, the first to test the structural design, the second to assess the space inside for components and access, and the third as the actual flight model.
The structure was of strong ring and stringer construction, braced by an aluminium outer skin 48,000th of an inch thick.
A range of testing was done, including shock loads to 40 G, vibration testing, centrifuge testing, torsional braking, and more.
Over 70 strain gauges were used to measure the deformations produced. Drop tests were done to simulate the effects of acceleration with short rise time, such as might occur during launch or the firing of the upper stages.
It was even placed in a vacuum chamber where the temperature was alternated from -15 to +50 degrees centigrade to simulate orbit conditions. When it passed all these tests, it was flown to Canberra and driven out to the Oriole Valley Tracking Station and placed in a specialised screened room to confirm that Wresat radios could communicate with the ground receiving dishes. It was then flown to Woomera to prepare for launch.
With the arrival of the Wresat cone from Canberra, final checks and assembly were begun. The cone was checked out and explosive components were fitted. The sensors received a final check using a hydrogen light source rich in ultraviolet. The space between was flushed with nitrogen gas to prevent oxygen absorption. The radar transponder received a final check. Finally, the covers were fitted, the nose cone was screwed down, and Wresat was ready. It was then taken to the launching area for mating to the rocket. Here, with great care, to the relief of some and the confusion of the skeptics, it mated up perfectly, and the whole assembly was ready for launching. Erection was completed, the umbilical cord was attached. Through this cord, monitoring functions were maintained, and power was supplied to ignite the rocket engines. In the nearby control van, missile functions were checked. When all was well, the countdown began. The optical tracker had a hazy view of the launcher scene due to the high ground temperature. As the countdown proceeds, the heater-cooler drop tank is shed. Liftoff.
Wresat was launched on 29 November 1967 using a modified American Redstone Sparta rocket from the Woomera test range in South Australia. In doing so, Australia became the 7th nation to have a satellite and the 3rd nation to build and launch a satellite from its own territory after the Soviet Union and the United States.
passes through an atmospheric layer of high humidity. The line of fire is 6 degrees east of north. The tracking camera loses the missile, finds it again. The first stage is all burnt. It separates and falls away into the Simpson Desert. The second stage was destined to fall into the Gulf of Carpentaria to the north of Australia, but heating on re-entry may have burnt it up. Its fall was not observed. Final injection into orbit occurred at latitude 27 degrees 30 minutes south.
Bearing an early forward-bounding kangaroo logo, Wresat operated in a nearly polar orbit. It completed 642 orbits and transmitted scientific information for 73 of those to tracking and research stations around the world. The experiments on board were designed by the University of Adelaide and had to be transmitted as radio waves back to Earth, as the satellite was to burn up upon return. The main Wresat experiment provided information on the solar radiation flux in wavelengths that have a direct influence on the temperature structure at heights above 30 kilometers, and assisted in the determination of the composition of the upper atmosphere above the homopause at approximately 100 kilometers.
An energy dissipator, consisting of a closed loop of aluminium tubing filled with silicone oil, was fitted to change the axis of satellite spin quickly so that the sideways and forward-facing experiments would be exposed to the sun as the satellite spun.
Direct measurement of the solar flux provided data on solar activity. The project also presented an opportunity for a united approach to a scientific problem with demanding requirements. Both the US and the UK provided assistance on the project, including the US Department of Defense, NASA, and the UK's Ministry of Technology. It re-entered the Earth's atmosphere and was destroyed by the resultant high temperatures on the 10th of January 1968, somewhere over the Atlantic Ocean west of Ireland. The RAAF Woomera Range Complex continues to be a major Australian military and civil aerospace facility and operation, located in South Australia, approximately 450 kilometres northwest of Adelaide.